Here's a bit of periodic table stuff, some basics and a few facts to help with exams. So you might want a periodic table to look at during this, would help greatly. So they're in the back of most books. They're also on the back of the chemistry paper. So remember, when you're in the exam, there is a periodic table on the back page. So in a general periodic table, all the metals are on the left side. So pretty much, and in the middle. So the left side and the middle, they are all metals. Obviously, if you look at the periodic table, there are significantly more metals than non-metals, but everything in the middle and to the left, they are metals. Anything on the right, the very far side on the right, they're non-metals. So if an element is on the left, it has to be a metal. There are no non-metals on the left side of the periodic table. If it's on the right, and I mean right over to the far side of the right, it's a non-metal. Now, groups on the periodic table are vertical. So the vertical columns, they're groups. We don't really look at the middle in edexcel. They're called transition metals, and we don't look at them. So there's two on the left, group 1, and logically group 2 after it. Then there's a big space. Then we have group 3, group 4, group 5, group 6, group 7, and then group 0. At GCSE, we're only really concerned about group 1 on the very left, and the last two on the very right, group 7, which are non-metals, and they've got all of the fluorine, chlorine, bromine in it. And the ones on the very end, the group 0s, the noble gases, they're something that we call inert, which means they don't react with anything. So group 0 are on the very far right, and group 1 is on the very far left. Group 1, obviously all metals. Group 0, they are non-metals, and they don't react with anything, that lot on the right. All elements in the same group, so the same column, they all have very similar properties. So group 7, you've got fluorine, cleans your teeth, chlorine, which cleans swimming pools, bromine and stuff. They all kill and clean stuff violently, really. Same with the group 1s. As you go down, all of those elements do very similar things. They look the same and do the same and feel the same. So periods go across. Now, the mistake most students make is that they don't realise that hydrogen and helium at the top, only two elements, they're the first period. What a period means is how many shells it's got, or how many orbits something has. So hydrogen and helium only have one. Then you go down, next one, so the line across like the horizon, okay, that is period 2. All of those elements along that long row, they have 2 shells, or 2 orbits, as some people like to call it. Then there's 3, and all of those have 3 orbits, 3 shells, and so on. So they go across like the horizon. They're rows, essentially. And groups are the columns that go down. Now, probably seen pictures around. There's a guy who looks a bit like a serial killer, bald head, big beard, psychopathic eyes. He's called Mendeleev. He's mentioned a lot because he created the periodic table. But this is hundreds of years ago. So when he create the periodic table, we hadn't discovered all of the elements, and he realized this and left small gaps in his periodic table and said, in the future, we're going to discover an element that will fit right in those spaces, and he was right. When we found them, we realized that they did fill in those gaps, and now we have a complete periodic table. So one of the big differences between Mendeleev's periodic table and the modern one is that his wasn't complete, loads of spaces in it, and he wasn't quite right because he didn't do it by atomic number. He didn't put the elements in order always by the number of protons. He put them in how heavy they were, which is a terrible science thing to say, but we have to say mass. And sometimes it wasn't quite right, but he was pretty accurate. So he was right because all of the elements that we discovered fitted into his table perfectly. And it was very easy for him to predict what we would find based on that. So facts to know, there is a word called isotope. Now, not all elements have the same number of neutrons in all atoms. Some have an extra 1 or 2, sometimes even 3 or 4. So an element, for example, carbon is the best example. Carbon usually has 12 neutrons. Most carbon atoms have 12 neutrons, but there are rarer versions that have 13, 14, and even 15. And these are all isotopes of carbon. They're versions of carbon, and those versions have extra neutrons. So if anybody asks what is an isotope, the answer is a version of an element with more neutrons than the normal one. And fun fact 2, which is the last fun fact, the elements are arranged in order. Hydrogen is number 1, helium is number 2, lithium is number 3, beryllium is number 4, boron is number 5, carbon is number 6, and so on. Now these numbers are not random, it's not alphabetical, they are in order by how many protons that element has. And in fact, that number is called the proton number. But hydrogen has one proton. It can't have two, because if it has two, it becomes helium. All heliums have two, and if it had three, it would be lithium. So the number of protons tells you which element it is. For example, all nitrogen atoms have 7 protons, and so its number is 7, and it comes in place number 7 on the periodic table.